Good afternoon, ladies and gentlemen. I think it's too early to go to bed, isn't it? We'll try again. Good afternoon, ladies and gentlemen. Good afternoon. Thank you. First of all, I'd like to thank Jim, Jose, Hugo for inviting me here, back to the university again. Do you know how long ago was that, since I was here? That's during Professor Rushbar's time, 1977. That's that long, all right? In fact, it's a pleasure for me to be back today to share my knowledge and experience with all of you. The title I'm going to present this afternoon is Sustainable Fire Engineering is the Future. Because everybody is talking about green. Now we are looking at whether green, is it sustainable? If it is not, then perhaps we should go back to the drawing board. Fire engineering aspect in construction industry. Where do we come in? And I think that is very, very important. Because if fire engineers are not involved during the planning stage, a lot of the decision has been made. And by the time we are involved, it's normally too late. As was pointed out by Jose in many of his international conferences. This is roughly the flow chart for any projects. Initially, you get the authority and insurance requirements. The owner will then take a look at what he wanted to build. Whether is it an office, or is it a compartmental store, or is it a shopping center? The requirements are all different. After that, you get a consultant to provide him with a design. Consultant, of course, will then consult the building bylaws. And then you have to get the documents approved by the authority having jurisdiction. Mechanical and electrical engineers will then incorporate various types of fire protection systems. After that, once the building has been approved, you go through the tender stage to secure all the relevant subcontractors. And then there will be an installation part. After which, the system will have to be tested and commissioned before the building can be in operation. But there are so many things that can go wrong. First of all, conceptually, we must get it right, failing which nothing works later on. Or it may seem to work, but then there are no risks involved as far as life safety is concerned. Nowadays, as we know, everybody tries to outbeat each other, building taller and bigger buildings. For example, now they are planning a tall building in Shanghai, and I was last told that in the Middle East, they're trying to build a tall building that is about 1 kilometer tall. So we were having a discussion the other day, and they asked me, what do you think for mass evacuation? I say for the apartment blocks that goes beyond 50 stories, what the developer need to give as a bonus to the building owners or the apartment owners. They can have a choice either a parachute or a hang glider. Once the building is completed, you need to do proper maintenance. A lot of people spend a lot of money building buildings, but they fail to maintain. At the end, everything becomes a white elephant. This is actually a high-speed water deluge system at workstation in ammunition depot. They use optical detectors joined up by optic fiber to have a response of probably about 100 milliseconds to activate the suppression system. It's very effective. But then Singapore, when they built their ammunition depot, they changed the concept. They said, why should we go to that extent to allow a fire to happen and then trying to put it out? It's always lousy to have post-fire action. I think nowadays we should look at pre-fire, preventing things from happening. So what they did is that for the ammunition depot, for that few rooms that they store as a storage, they lower the oxygen content so that no fire can ever happen. Well, that's the new thinking, and of course there are other safety measures that they have to deploy. I think nowadays all the fire engineers will have to look at changes in our environment. We cannot just look at internal, we have to also look at the external factor that's going to affect the design of a building. Tell me, bungee jumping is more hazardous or driving on the motorway?
Motorway.
Why?
There's more of it.
Big volume.
Big problem.
Big volume.
Big volume.
People.
I think you're looking at the duration of exposure to risk. Agree? I did my bungee jumping in Wellington, in Queenstown, in New Zealand. The whole process was over in about 5 seconds. Driving from here to London takes you, what, 5 hours? So you look at the duration of exposure to risk. If you happen to be born in one of these countries around this so-called ring of fire, Asia ring of fire, you are a little bit unfortunate. Alright, so you see, sometimes risk is beyond our control. I think all of you are aware of this natural disaster that until today, Japanese government is trying to deal with it. Now Japan, I believe, other than US, they are one of the most well-prepared countries in the world. Now how on earth all this happened? But when we start looking at the precaution measures that's been taken, suddenly we find that there's still room for improvement. Of course, there are a lot of other reasons that I do not want to mention here. Apparently, about 3 months before the disaster struck, they're supposed to carry out a risk assessment exercise. And they did not carry it out, but rather fake a risk assessment report. So you see, things can also happen in advanced countries like in Japan. They do anticipate earthquake and tsunami, but the design of a wall to stop the tsunami wave wasn't high enough. So you have the disaster. Can you imagine such a beautiful country? It's totally destroyed. And the problem does not stop there. With the radiation, probably a lot of places will not be habitable for the next, I do not know how many decades. We cannot ignore the force of the nature. If you look at all these pictures, paints 1,000 words. One lesson we learn out of that. If you look at this particular township near the coastal area, only the concrete structure building remains behind. The rest of the wooden buildings are all gone. And yet they are green. So, how do we look at sustainable built environment? We have to look at challenges ahead. So, green building, sustainable construction, are they the same? Or are they variants? For green construction, you look at preservation of environment, usage of natural resources for construction, material must be recyclable, system must be energy efficient, must produce minimum carbon footprint, and the manufacturing process must also be energy efficient. And of course, you must use as much as possible natural resources with reduction of chemical-based products. But built environment is not sustainable if it produces large carbon footprint when burnt. Use of natural resources outweigh the recyclable period. For example, timber, yes, you can grow a tree again, but if timber construction is easily burned and a tree takes 20 years to grow, you can do the mathematics. Byproduct of timber and petroleum also cause pollution. If you look at synthetic product and the organic product, there is a lot of difference in the byproduct that is generated due to a fire incident. Now we are also looking at fire suppression of water mixed with pollutants, also pollutes the environment, and they also need recovery now. This is a very, very expensive exercise, and they're still pondering how to do it properly. Green construction, even though we are deliberating now, is definitely going to change the construction industry. But the impact probably will take decades or more to assess. If you look at the major fires nowadays, the tank farm fires, the amount of pollution is terrible. In Europe and in other parts of the world, they are trying to experiment with timber frame building. But it does produce a lot of fire risk for the firefighters. In fact, when we were in one of the conference, the Deputy Commissioner of London Fire Brigade is saying that, in fact, with this type of construction, their firefighters are safer now, because by the time they get onto the fire scene, everything was burned down. Firefighters don't even need to go in, risk their life and go into the scene. It may be a joke, but then it reflects the irony part of the so-called green concept. There are a lot of so-called innovative designs of drywall construction. But if you look at the materials that has been selected, not only they are highly combustible, they're also the byproduct of the insulation material is also highly toxic. So I think we should not be just looking at one particular criteria. So in Malaysia now, we are looking at using toxicity as mandatory criteria for selection of materials. Worst of all is that if you look at this particular facade, you'll be thinking that it's all timber, but it's not a timber particle facade. Internally, they could have used a lot of so-called combustible material. Innovation also goes to beams. And then when you cover up with plywoods, you can see the result. So are we building safer habitats nowadays? The so-called green concept. This looks like brick, but because it's just a very thin facade, there is mounted on timber structure. Now flames spread internally. Firefighters can't gauge where the flame goes. Looks like a concrete wall, but is it concrete? It's not. It's chipboard. You can see that. Camouflage with only a mortar, layer of mortar externally. I think the danger about all these new form of or innovative drywall system is, other than withstanding the fire rating, can they withstand also the pressure of the jet when the firefighters put it on? After 1 hour, the whole structure might collapse under pressure. So you see, they are more than just talking about toxicity of the material. We are also looking at the life safety of the firefighters, because when you have a fire alarm, everybody else runs out of the building. Who runs in? Firefighters. Reduction of chemical products, which is the right direction to go. EU remove many of the fire retardant chemicals. I think that's the way forward. But that also have its implication, because now more construction materials will be reclassified as combustible. In the past, we impregnate those materials with fire retardant chemicals, but nowadays, with those prohibited to be used, carpets and all that will then become combustible. Also, there is a trend, I believe Europe already did it. Dry chemical powder is not allowed to be used for portable fire extinguisher. In fact, if you look at dry chemical powder, they're actually chemical based. And because of the world shortage of food, dry chemical powder actually is being used as fertilizer. So there will be a competition, a great competition. And definitely the food industry will need more fertilizers than the fire industry. So European now has turned to water and foam. I do not know whether any one of you have tried your hand on the dry chemical fire extinguisher. Have anybody tried that, using one? Do you find a stench smell coming out of the powder? And one word of advice, you better make sure you select the upwind area. Otherwise you might look like a Christmas tree. Oops. This is a list of all the insulation materials. On the look of it, a lot of them are very good insulation or thermal property. But if you look again, it's only 3 that is non-combustible. Alright? If you look at this particular column, the one under EN 13501 class 1, that is the combustibility classification. A1, A2 is non-combustible. From B onward to F, the degree of combustibility increases. But yet, a lot of people choose foam because they're cheap. Not only they're cheap to purchase, they're cheap to work with as well. Next thing we're going to look at is fire hazards and fire risks. Fire nowadays, the modern fire, so-called modern fire, changes in character, changes in duration, changes in many, many things, because we use so many types of synthetic materials. Modern synthetic materials generates high heat flux, moderate smoke intensity, but ever presence of toxicity. And through that, it increases pyrolysis process and shortens flashover period. That make it very, very dangerous. Now, most of the buildings, when they are constructed, architects will design very basic finishes. Most of the internal finishes are all carried out by interior decorator. This group of people, they are not under any jurisdiction. They do not need any approval. And yet, they are the one who put in all the fire risks into the building. Because of budget constraint, normally interior decorators are, when they put in furnishings, they look for economical materials with aesthetic value. But a lot of these materials are highly combustible. That's reflected in so many fire incidents in the world. So fire hazards and fire risks will definitely increase with time. how long do you think you achieve flashover in a common room? Anybody want to give me a guess? One of the right answer can go for tea now. Oops. I think yes. No, still it's not moving. It's actually a video. It's an experiment carried out. A candle was left on this couch, and you can see the entire development of fire in this particular room. Because of the software difference, I can't get it to work. No. Oh. Okay, never mind. I'll see whether I can get it to work after this. Fire hazards. We look at now flammability, combustibility. We also look at smoke intensity, because that is very important if you're looking at mass evacuation. And we are now also looking at toxicity. So a combination of either one or all of them spells danger for occupants. As I pointed out just now, we are also now building mega-sized project. What are the risks? Supervision problem. We have a lot of these problems even back in our own country. When the projects get so big and the owner have a deadline to complete and open, the engineer, even with the supervisor, cannot supervise every corner of the building. And that is one of the major problems. Also, mega-sized building comes with mixed risk occupancy. It's very different from office block or hotel block. You have office, hotel, apartment, shopping center, restaurants, everything within a complex. More important, the turnover of the tenant. You could have conduct safe briefing for the tenant, but if the turnover of the tenant is large, then you're going to have another problem. Plus, a new tenant could have bring in new risks. Just like a telco company that occupies 3 floors of a tower block. Imagine how many tons of the PVC cable they're going to bring in with them. And because of the sheer size of the project, maximum travel distance is often exceeded. If you go into one of the major shopping centers nowadays, it'll be a hard time finding the escape route if you're not familiar. And under the influence of smoke and heat and the commotion, orientation of direction will become a problem, especially with the seasonal crowd density. During the festive seasons, the crowd intensity definitely increases. What about tourists who comes into the country, they're not familiar with the language? So crowd control becomes one of the major problems for modern construction during emergency. And it's very, very difficult because human beings are at times not controllable. You can set up a lot of procedure, you can do a lot of drills under panic condition. Everybody behave very differently. You're looking at fire. What about gas, explosion, tremors, possible terrorist attack? Who is going to manage all this? So it's no more a building owner's problem. The emergency response planning and management must be jointly conducted by building owners, fire authorities, civil defense force, national city council, etc. And it must be conducted with tabletop drills, followed by actual drills. Twin Tower in KL, how do you evacuate all the occupants? We divide the building into two halves. So if you have fire on the lower tower, on the left-hand side block, the top two halves of the tower will be asked to evacuate by staircase. The tower on fire, the occupants will be asked to cross over on the sky bridge on the 41st and 42nd floor. And after that, all of them will be taken down by high-speed lifts. But having said that, this cannot be a general ruling applying for all high-rise buildings, because it has to be carefully planned and it also must be managed. Which means that the management must have sufficient personnel to be trained and to manage all the crowd. All the lifts are operated by operators, not by the occupants. Everybody is trying to beat each other. I mean, how are you going to evacuate buildings of this nature? I was in Hong Kong recently, and now Hong Kong, they have a building requirement that every 25 floors for high-rise buildings, you must provide a refuge floor. Of course, they are saying that if the building is about 80 stories high, not everybody can evacuate by staircase from the top to the bottom. I agree. So they set up refuge floor for you to have a rest. Sounds all very good, and they also break the continuity of the staircase. So every 25 floors, you have to go around the refuge floor to descend by the other staircase. The thought behind that is that if you have one staircase going from the top floor all the way to the ground floor, in case the fire or the smoke gets into the staircase, nobody else can get up. But if you break the staircase, of course, it's safer. But there are a lot of other observations that I did, and since the camera is on, I don't think I want to talk about it here. All right? Tea time, we can discuss. There are a lot of things that has to be done because it has to be managed. When people start to rest, the question is who or when are they going to carry on? If you rest for 30 minutes, the situation below, assuming the fire is below, has it escalated to what stage? Is it safe to carry on? Or is it safe to actually stay behind for the firefighters to come and rescue? Who is going to manage all this? There are a lot of question marks. What about provision for disabled, sick, pregnant ladies? Injuries during egress. A lot of people panic, they slip down the staircase, break their arm, break their leg. What about those who have suffered possible heart attacks? Are the management ready for all these emergencies? Or they expect everybody to be young and healthy? So lift evacuation must be accompanied by a well-drilled and managed program. And I think the most important thing is that you must protect the fire escape staircase integrity. If you look at fire escape staircases, every floor is guarded by a fire door. And yet, a lot of these doors are actually whole in open position. There's no compartmentation. Sometimes I was wondering, because when I look at the door, it has a tag that says fire door kept shut. Then you look at asset must be higher than reset, with minimum clear smoke height, especially for car park, underground car parks. Fire engineering performance-based design has sprung up over the last 5 years. But again, there are a lot of debates going on at the moment as to, is this the future? But all of us know that there's just insufficient data bank on fire behavior. So all the fire safety engineers who perform this, what is their basis? It's basing on 3 engineers' assumption. How long is that assumption going to last? Because when they hand over the building, assumption is still valid. Even that, I do not think there's sufficient studies being carried out. But what happened after that? 5 years down the road, the owner doesn't understand what do you mean by fire engineering performance base. The building manager also doesn't understand what is happening. So they start to look at this space is left vacant. It's a waste because commercially they want to make use of every square feet. So they start putting in shops. They start putting in a lot of things. And suddenly you find that your mass evacuation circulation area has been reduced. Your fuel load has increased. Sometimes they move the risk elsewhere. So if you look at 5 years down the road or 10 years down the road, are all the assumptions still valid? What about human behavior? We design a lot of things. Did we actually look into human behaviors? Because human beings are irrational. A lot of people, if you tell them to go right, you purposely go left. Because they say, why should I listen to you? Right? Challenge a lot of engineers, fire protection engineers. They say, I designed the fire alarm system according to a British standard. I said, prove it to me that it's going to work. You expect everybody to hear the alarm and walk out of the building? I said, no chance. And this has been proven in Australia many years ago through a full-scale investigation. What is the reason? Because a lot of engineers who design fire alarm and detection system, they do not factor in acoustic engineering. You need to do that because you are talking about human beings. A lot of human beings, they do not move because it's very simple. I don't see the fire or smoke. There's no danger. Or everyone is behaving normally, especially in big shopping center. And this lady who has waited 7 months for the mink coat at 70% and the shoes and the handbag. He said, you want me to go before I get this over my dead body? So you see, everybody got his own reason, right? And some of them will say, what is that noise about? So public education is also very important. There are other reasons too, design fault. Audible alarm level, many a times is masked by interior finishes. Because sound, energy travels, as it travels through the air, it loses energy. If it bounces at the surface, part of the energy is absorbed, part reflected. But all these are not being taken into consideration. Also, if you place the audio and visual alarm units, you look at whether did they cover, they must be overlapping. If not, you have a space in between that the noise level will drop below 65 dBA that is required according to British standard. So, what happened to your asset? Let's look at the required safe egress time first. How do you work it out? You look at the time of detection. That depends on what type of detector you have installed in the building. If it is not so sensitive, then of course it takes a longer period of time. And then the time for brief movement. After you hear it, sometimes you don't move straight away. And also after that, the time of movement. So when you add these 3 factors together, then only you get your reset. And it varies, of course. It varies according to different type of building and all that. But if your reset is higher than your asset, then you know you've been in trouble. So to have a better chance, normally you have to look at compartmentation, protected corridor, fire escape staircases, active fire protection system, smoke management system. I always say is that if a fire engineer, after graduated from the university, did not continue developing his knowledge or his experience, everybody will be in trouble. Because we all rely on fire engineers to provide us with efficient design. So the competency of fire professionals are very, very important. The higher the fire hazard, the more critical. We also find that for tank farm protection, a lot of engineers, they design the hydrant and the monitor so close to the wall of the tank farm. Do you think it's accessible? The heat generated when a tank went on fire is so high. The last time we had one in Malaysia, the fire authority, at first they positioned themselves about 100 feet. When the tank farm goes on, they have to move 200, 300 feet. So you see, many of times we just follow the old design without reviewing. Engineers also got to keep in line with the latest fire protection concept and technology, because everything moves, we improve. And if you are not in line with that, then of course, whatever design that you incorporated might not be appropriate. And they also must keep in line with the latest codes and standards, because codes and standards are dynamic. It changes all the time, probably every 5 years. Therefore, fire engineers must log their CPD activities. In Malaysia, in order to persuade the fire engineers and architects to be more understanding about the fire hazard, we bring all of them for firefighters training. Straight away, they realize what do you mean by heat, what do you mean by smoke, you know. Rather than talking to them so many years, I say, all you have to do is go into that container, and you notice this is a 40-footer container, and the door is open. We tell them, you study the smoke layer, look at the heat, and the one in the front, the moment we lighted the fire, he wanted to go home. It's unbearable. Just now there's Class A fire we're fighting, this is Class B, and all these members, they have no experience, but they are instructors around that make it very safe. We use water spray, 60-degree angle to contain the fire, and the second guy is supposed to turn off the gas valve. He suddenly finds his hand is 6 inches shorter. This is a night chemical spill fire, and you see that the areas where the water cannot reach, the fire attacks. Here, when it goes close enough to the fireball, you can see the fireball rolling inside the thin layer of water. This is also to teach the members that water under specific pressure is good enough to contain fire of that, because these are petrol pump at about 5 bars pressure coming out of the leaking pipe. And this exercise will be there in front of the fire for about 3 minutes. And mind you, all these are non-experienced members. Okay, the other factor that we have to look at is quality assurance of fire protection system. All fire protection products and systems need systematic verification process to ensure functionality upon completion. There are 1,001 things that can go wrong, because if you look at a complicated system like a sprinkler system, they have so many components. Each of the components must be tested and verified according to a standard. So laboratory test criteria is very, very important. A lot of these suppliers, they are very smart. They go to a laboratory and test, but not to the standard that is being required. After that, you imagine when they produce a prototype, they spend so much time. Now, when you go into production, the quality drops. If it is within the tolerance level, it's acceptable. But most of the time, we have to be very, very careful. This is a fire door. I don't know whether I can get this to run. In Malaysia, Fire doors are all subjected to test, to BS 476, Part 20 and 22. But we have been collecting feedbacks from the market whereby fire doors fail within a very short period of time, 24 months to 36 months. We're wondering why, because normally one of these doors is supposed to last at least 10 years. Then I realized it's just like a car tire. It's subjected to wear and tear because the door you open for access. So the authorities having jurisdiction pick up doors that has been approved, that is marketed on the market before they've been installed in the project, bring it back to the laboratory and test. They fail at 15 to 29 minutes. So you see, a product that is already tested, passed a test, got a test report, does not even stand up. So the system must be tested to fulfill all criteria. After that, we must monitor, and I do understand that EN, they have this marking scheme, listing scheme, it's all very well, but still you wanted to do verification. Smoke extract system for underground car park is another very interesting area, because nowadays, commercially, a lot of building owners, they reduce the floor height. When they reduce the floor height to save structural costs, proper fire-rated smoke extract duct system cannot be used because it's too low. So they revert to jet fan system. The problem with jet fan is that this particular system originally was designed for tunnel smoke extract system. But then tunnel is mostly two-dimensional, as we know. If you look at a car park that is about 5,000 meters square, it's huge. How do you ensure the smoke travels in the direction that you wanted to extract? So I was invited for, they call it a test, I call it a demo, because there's no procedure, there's nothing. So I said, okay, I'll go and have a look. And what they did is, first thing, you see the level of the car park is very low. And by right, the fan must be installed below the beams, because all these beams actually form pockets. And how on earth is the jet fan going to move the smoke along if they're all trapped by the beams? You look at it. Anyway, they perform the test using cold smoke, and that is another area that I disagree, because in the actual fire situation, you are encountering hot smoke, not cold smoke. Of course, everybody is very comfortable in the car park walking around. Nothing happened to them. I said, just imagine if all these are heated particles, 120 degrees C, I think all of us would have been dead. So they fill up the car park, and that is not supposed to be the condition, because you should achieve a clear height of at least 2.1 or 2.2 meters so that people can escape, right? This test method is not accurate. So they started the fan, and it works, all right? After a while, all the smoke was extracted, but dragging through the entire car park. Okay. This is when installed in the corner. I also don't know how it's going to move the smoke particles along. Now this is the extract system, right? All the smoke is moved to this corner according to the concept, and it's going to be extracted through the duct. But look again, next to it is the fire escape door. If you are going to move all the smoke to this particular area, how is people going to escape through that door? Right? And this is inside the duct. Now, a duct of that size, when you apply negative pressure so that you can remove smoke particles, if you do not struck it properly, the duct will collapse. This was tested in BRE before, and the duct imploded. And see what they use? They use timber. also there's a lift lobby going right into the car park from the above, and they use glass door. This is supposed to be a fire rated door. It's so dangerous. Even though they told me there's a shutter, metal shutter coming down from behind, but I say if you use a metal shutter that's not insulated, there'll be heat transmitted due to radiation. Anybody inside there is going to die. Fire engineering approach, performance-based design is best suited for mega projects. But there are a lot of engineers who are using this to legally apply for waiver, which is very dangerous. And especially if you have a building that you only apply for part of it, it's even more dangerous. Most of these design, if you use CFD, should be verified using hot smoke test. That's been carried out in Hong Kong quite successfully, twice, 3 times. And they should be verified through a peer review report. You need a third party's view. Because some of these are employed by the owner, and if you are employed by the owner, again, there is some ambiguity there. Authority having jurisdiction that's granting approval also need to be very well versed with the concept, because if your engineers or if the fire officers do not have the knowledge, they can't verify. Then the next question is, then how can you give the approval? I think Hong Kong is one of the fire authorities that have a lot of qualified fire engineers in this area. Also, final occupancy hazard of the building need to be clearly defined, because that's the basis for the assumption. So the engineer who is designing must understand the ultimate utility of the building, or the building, how the building is going to be used, in what sense, what type of hazard, what type of fuel load, what kind of smoke index, or the heat flux that's going to be generated. Not only that, I think they need a continuity of this particular concept for maintenance of the fire engineering performance base. And Singapore authority actually make it mandatory for the building owner to engage such engineer to maintain the building. I think that is the only country that did that. So, sustainable fire safety engineering, in conclusion, the way forward should include the following considerations: life safety of occupants, life safety of fire engineers, firefighters. Adopt sustainable fire safety engineering approach, not just green. We have to try to reduce combustible materials to reduce the heat flux, and use quality assurance fire protection products and systems. All fire escape paths, fire escape staircases, the integrity must be ensured and maintained at all times. And I also believe it's everybody's part to introduce, induce, and maintain fire safety culture in the entire community. If you look at in the past, if you go through all the airports, there's no announcement. Now they announce so often that if you see luggage unattended to, please notify the security. So it becomes now part of life, of your life. You go through airport, you start looking around. Yes, that's fantastic education, but not in the fire safety area yet. We also must induce preventive maintenance of active and passive fire protection concept, products, and systems, because you do not wait for product to fail, then you change. Some of these protections are critical. By the time it fails, and the layover is too long, you do not have any protection. So this is very, very important. And when I was in Australia, they are talking about using RFID system to tag all the major components of active and passive fire protection systems, so that when the maintenance period is up, you know, not only that, you know who is doing the job, you know how long they take, what is the layover period, everything is recorded online. Must also engage qualified fire safety managers, engineers, and technicians. There are so many who claim they are fire expert, yeah, but who verifies that? There are so many cases going on. To select non-combustible or fire retardant, not fire retardant, fire resistant products. Design should also take into consideration of reset and asset, which is not being applied by a lot of engineers. And fire escape staircases should be located at the furthest distance from each other. A lot of architects, they like to put two staircases back to back in the same shaft. They have not learned from the 911 incidents. When there's an explosion, you have nothing, all right? So you need redundancy. Redundancy means that if one of it was destroyed due to any reason, you still have another one to go down. If you put two together, of course, in design-wise, it saves a lot of money, but it's not safe. Design should also integrate passive and active fire protection concept. Both must go together. You cannot rely on active because they are post-fire scenario that is not so good. And I think we should also look at specific occupancy risks. I presented a paper at the Asia Built Hospital conference. I asked them a simple question, they have no answer. I said, you spend so much money tagging all your patients. How much money do you spend to evacuate all your patients whenever there's a fire incident? Just imagine newborn babies. Where are you going to put them? Assembling area? Newborn babies? What about ICU patients? And I say you also need a weather forecast expert, a consultant. How do you know it's not going to be raining outside that day? What about the commotions when the fire protection system operates, sprinkler system operates with the smoke? Will the patient die of heart attack? Thank you.
A tremendous talk, everyone, and very, very powerful questions. Gives us a lot to think about. Time now for a break, time to network. We're back for 6 o'clock, that would be great. So if you're out the door at the top there, you'll find there's teas and coffees and refreshments there for you. Thank you very much.